Hello my dear students, in this video we will continue with the other components of the motherboard, that is input output ports and interfaces. The ports and interfaces are used to connect external devices like printers, keyboards or scanners to the computer, which gets connected to the computer's motherboard. These ports and interfaces are found on the rear side of a computer, that is back side of a computer. There are several types of ports like serial port, parallel port, USB port and AGP, that is accelerated graphic port, etc. So let us continue with the first one, serial port. Serial port is also known as communication or COM port, or it is also called as RS-232C ports. They are used for connecting communication devices like mouse and modem. This port transfers data serially one bit at a time. It needs a single wire to transmit one bit of data. Hence, it takes 8 times longer to transfer a byte, because a byte consisting of total 8 bits. Hence, it takes 8 times longer to transfer a byte. There are two variables of COM ports, the 9-pin port and 25-pin port. Here on the rear end you can see all the different types of ports and each port is labeled with its name. Now let us move on to parallel port. Parallel ports are used to connect external input output devices like printers or scanners. This port facilitates the parallel transfer of data, usually 1 byte, that is 8 bits at a time. Parallel ports come in the form of 25-pin connector. Let us continue with IDE, Integrated Digital Electronics Port. IDE devices like CD-ROM drives or hard disk drives are connected to the motherboard through the IDE port. Let us continue with USB, that is Universal Serial Bus. USB supports a data speed of 12 megabits per second, supporting up to 127 devices. USB is a plug and play interface between a computer and add-on devices. Devices include printers, scanners, digital cameras, web cameras, speakers, etc. And the diagram of USB is given here in the diagram. Let us move on to Ps2 port, that is Personal System 2 port, which is normally used to insert or to connect keyboard as well as the mouse. The Ps2 port was developed by IBM to interface keyboards and pointing devices like mouse, trackball and touchpads. So all these are input devices. Now AGP, accelerated graphic port. The AGP port is used to connect to graphic card that provides high speed video performance typically required in gaming and other multimedia applications. Let us continue with SCSI, that is Small Computer System Interface Port. This port is used for adding external devices such as high-speed hard disks, high-end scanners and CD-ROM drives. It does fast data transfer and input-output operations. VGA, Visual Graphics Adapter Port, connects monitor to a computer's video card. It has 15 holes and is similar to serial port. But serial port connector has pins, this has holes. Let us continue with power connector. So this has 3-pronged plug. It connects to the computer's power cable that plugs into a power bar or wall socket. Fire port, transfer large amount of data at very fast speed. It connects camcorders and video equipments to the computer. The data travels at a 400 to 800 megabits per second. It is invented by Apple. The 3 variants of Firewire port are 4-pin Firewire 400 connector, 6-pin Firewire 400 connector and 9-pin Firewire 800 connector. Modem, modulator, demodulator, connects a PC modem to the telephone network. Ethernet port connects to a network and high-speed internet. It connects network cable to a computer. This port resides on an Ethernet card. Data travels at 10 megabits to 1000 megabits per second, depending upon the network bandwidth. Game port connects a PC to a joystick. It is now replaced by USB. DVI, Digital Video Interface Port, connects a flat panel LCD, that is liquid crystal display monitor, to the computer's high-end video graphics card. Sockets, these are used to connect microphone, speakers to sound card of the computer. The next is Midi, Musical Instrument Digital Interface Port. It is a system designed to transmit information between electronic musical instruments. A Midi musical keyboard can be attached to a computer and allow a performer to play music that is captured by the computer system as a sequence of musical notes with the associated timings instead of recording digitized sound waves. The port and interface are required for connectivity. Here is the diagram of Midi, that is musical instrument and digital interface. Next component of the motherboard is bus. A bus is a collection of parallel wires that forms a pathway to carry address, data and control signals. Memory. A computer memory refers to the electronic storage space for instructions and data. There are two basic types, internal memory and secondary memory. So let us continue with internal memory. Internal memory includes registers, cache memory and primary memory, which can be directly accessed by the processor. So here we can see in the diagram that consisting of a pyramid, accessing time is increasing from top to bottom, and even storage capacity increases from top to bottom. Means what? The register has got less access time, means it is faster and it has got less storage capacity, whereas the magnetic tape has got maximum access time because it is going to get delayed to access the data. Not only that, it has got the large storage capacity. First of all, the data will be searched by the CPU in registers. If it is not available, then it searches in a cache memory. If it is not available, then only it searches in a random access memory. Registers. The registers are high-speed temporary storage areas located inside the CPU. After the CPU gets the data and instructions from the cache or RAM, the data and instructions are moved to registers for processing. These registers work under the direction of the control unit, that is CU, to accept, store and transfer instructions or data and perform arithmetic or logical comparisons at high speed. Cache memory. The cache memory is a very high speed memory placed in between RAM and CPU. Here is the diagram that shows there are three different types of cache memory. Actually, we have got L1 cache, L2 cache and L3 cache is present in a latest computer system such as i3, i5, i7 processors. Here you can see the processor consisting of registers. Not only that, L1 cache memory is already embedded onto the processor itself and L2 cache is embedded on the motherboard. So here cache memory lies between the processor and the RAM, that is memory. And after that, you can see here we have got the hard disk, or you can say the secondary storage device. So here L1 is the fastest compared to L2 because L1 is directly embedded onto the microprocessor, that is the CPU itself. So hence it is faster. Generally, computers have cache memory of sizes 256 KB to 2 MB. The CPU has a built-in L1 cache, that is level 1 cache, and L2 cache. Some CPUs have a separate cache chip on the motherboard called level 3 cache. CPUs have the cache size varying from 256 KB L1, 6 MB L2 to 12 MB L3 cache memory. Primary memory. RAM temporarily stores the computer's operating system, application programs and current data so that the processor can reach them quickly. RAM is a faster memory and volatile in nature. That is, when the power is switched off, the data in this memory will be lost. Next, we will continue with ROM. ROM is a small memory which stores the boot firmware called BIOS, that is basic input output system, which we have already studied. So this particular memory consisting of instructions already written by the manufacturer. So this tells where exactly the operating system is stored onto the secondary storage device, from which it has to be loaded onto the RAM. BIOS hold enough information to enable the computer to check its hardware and loads its operating system into its RAM at the time of system booting. ROM is non-volatile in nature, that is, even when the computer is switched off, the content of ROM remains available. Why? Because all the instructions which are written by the manufacturer of the ROM is permanently available, and it will be helpful to boot the computer system. Types of random access memory. There are two different types. The first one is DRAM, that is dynamic RAM, and the second one is static RAM. Let us continue with the first one, that is dynamic RAM. It uses transistors and capacitors. The transistors are arranged in a matrix of rows and columns. The capacitors holds the bits of information, that is 0 and 1. The transistors and capacitors are paired to make a memory cell. The transistors act as a switch that lets the control circuitry on the memory chip read the capacitor or change its state. It must be refreshed continually to store information, otherwise it will lose what it is holding. The refresh operation occurs automatically thousands of times per second. DRAM is slow because the refreshing takes time. Access speed of DRAM ranges from 50 nanosecond to 150 nanosecond. Now let us continue with SRAM. Static RAM uses multiple transistors, that is 4 to 6 for each memory cell. It does not have a capacitor in each cell. It does not need constant refreshing and therefore is faster than DRAM. SRAM is more expensive than DRAM and it takes up more space. It stores information as long as it is supplied with power. SRAM is very fast and easier to use. The access speed of is from 2 to 10 nanosecond. SDRAM or synchronous dynamic random access memory is a special type of DRAM that is synchronized to the system clock. Since it is synchronized to the CPU, it knows when the cycle is coming and has the data ready when the CPU requests it. This increases efficiency by reducing CPU waiting time. DDR SDRAM or double data rate synchronous dynamic random access memory works the same way as does ordinary SDRAM. Data transfer rate is double when compared to SDRAM. Now let us continue with power supply to a computer system. Whenever we want to work on a computer system, it is required to have a continuous power supply. In the event of power failure, we require to have a backup of a power is called as UPS, that is uninterrupted power supply. There are two types of UPS. The first one is online UPS and one more is offline or standby UPS. Here in the diagram you can clearly see that the top diagram represent it is the standby UPS. In the event of power failure, the power is supplied to the load through the inverter from the battery. Here you can see the main is cut off. Once the main is switched on, then automatically it switches to the mains. The below diagram shows that the main power supply is on, the battery is getting charged by the battery charger, and through inverter the load is loading or getting the power. Usually computers converts 230 AC volt into 5 to 12 DC volts. Here the current is supplied by SMPS. So this SMPS is a small box which is there at the rear top side of the system unit, that is switched mode power supply. This SMPS, that is switched mode power supply, will convert 230 volt into 5 to 12 DC volts. Generally 5-inch color monitor will require to have 500 volt ampere UPS, and 17-inch color monitor requires to have 600 volt ampere UPS. That's all in this video. Thank you very much for watching this video. We will see you in the next video.